Hi, welcome back to Common Core Algebra II. Today's lesson is 6.2 factoring. Now, factoring is something that we have done in Algebra 1 extensively, and you should really be entering Algebra 2 with this skill. But speaking to some of you, we need to spend a little bit of time reviewing on this. So I want to remind you that this is really a gateway skill. This is a skill that you need. You just need it. You need it in Algebra 1. We told you needed it in Algebra 1. You needed it in geometry for a little bit, and you needed it in Algebra 2 a lot. So if you did not understand this in Algebra 1, this is the time to make sure that you are committing this to memory. All right, there's two important meanings to the word factor. There's the verb meaning to factor. So that means we're basically going to rewrite a quantity into its equivalent product. For example, if I consider like the number 12, 12 is equal to 3 times 4. So to factor 12 into its factors 3 times 4. So if you think about it as the noun, the 3 and the 4 are factors of a product, which is 12 in this case. All right, so whether it's a verb or a noun, because sometimes we'll say things like, well, factor this out, and that's basically a verb, it's an action. And the other one is, what is the factor? So there's your noun. So they're looking for a binomial or a number, something that's a part of the original product. Okay, so hopefully, once we get to exercise 1, some of this will start getting a little bit more familiar. So like I started with number 12, it says rewrite this as a product of only prime numbers. This is called prime factorization, and how I do prime factorization is I always find the first prime. And the first thing I always ask myself is, does 2 go in? Because what are my prime numbers? 2, 3, 5, 7, 9 doesn't go in, 11, so on and so forth, because prime numbers are numbers that are only divisible by 1 and itself. And 2 is a very special prime number. It's the first prime number. It's also the only even prime number, because every even number after that has 2 as a factor, so it won't be prime. So the number 12 is going to be 2 times 6, and I stay with 2 if my number is even. And 2 times 3, and as soon as I get to another prime, I know my prime factorization here is 2 times 2 times 3. I'm going to follow that same thought process with 30. Even though the first thing that comes to mind is 3 times 10, I'm going to stay with my process where I say it's 2 times 15. Now 2 doesn't go into 15, it's not even, so now I move to my 3. And I know this is 3 times 5, and 5 is prime. So I know my prime factorization here is 2 times 3 times 5. 16 is 2 times 8. I know 8 is 2 times 4, and I know 4 is 2 times 2. So this prime factorization is 2 times 2 times 2 times 2, which we know is the same thing as 2 to the 4th power. 36 is 2 times 18, which is 2 times 9, which is 3 times 3. So I know my prime factorization of this one is 2 times 2 times 3 times 3. All right, so always keep in mind that when we factor a quantity, we simply rewrite it using a different form that is completely equal to the original quantity. It might look different, but 2 times 3 is still the number 6. Exercise 2 says rewrite each of the following binomials. So rewrite each of the binomials. So what does the word binomial mean? It means basically 2 terms, an expression with 2 terms. So these are all expressions of 2 terms as the product of an integer with another or a different binomial. So basically what they're asking us to do here is to factor out what's called the GCF, the greatest common factor. I'm kind of getting ahead of myself. I kind of introduced that down below a little bit, but I asked myself, what number goes into 5 and into 10? And the answer is, of course, 5. So if I factor out a 5, which means I take a 5 out of each term, what do I have left? These cancel. I'm left with x plus, and 10 divided by 5 is 2. So 5 is a factor of 5x plus 10, and x plus 2 is also a factor of 5x plus 10. And if I just use the distributive property, I would get back exactly what I started with. So I want you to pause the video and do the rest of them, because these are pretty easy and I think you should be able to fly through them. Taking a look at B, obviously 2 and 6, my greatest common factor is going to be 2. I divide both sides by 2 and I get x minus 3. Now 6 and 15 in C, 6 does not go into 15, but does another number go into 6 and 15? And the answer is, of course, yes, because if I divide 6 in half to 3, I know 3 will work here. So when you factor out a 3, beware though, we're not going to be left with x, we're going to be left with 2x plus 5. And the same thing goes for D, where we have 6 and 14, and 2 goes in, but is there any number larger than that? 2, 4, no, 2 is the only one that's going to work. So let's take a 2 out. So divide each of these by 2, and we get 3 minus 7x. It's in a different format than the other binomials that we did, but it's still 2 is a factor of 6 minus 14x, and so is the 3 minus 7x. Okay, so what we just talked about again is called factorization. All right, so basically when you talk about the greatest common factors, it doesn't always have to just be numbers. It could be variables as well. So let's take a look at exercise 3. Because if we look at 3, the first thing I ask myself is, what number goes into 3 and 6? And it's pretty obvious that 3 goes in, but notice what I have here. I have 3 times x plus 6 times x. So notice how I have 2 x's on the left and 1 x on the right. So it means I can also pull out an x that's common to both of those terms. So if I pull out a 3x out of each one of these, and again, what that means is I divide each of these by 3x, what do I have left over? The 3's cancels and the x cancel, and I get x plus the x's cancel here, and 6 divided by 3 is 2. And again, I can give this a really quick check to see if I did this right. 3x times x, 3x times x is 3x squared, and 3 times positive 2 is positive 6, and I have an x left over, which is exactly what I started with at the beginning. So again, I'd like you to pause the video right now and see if you can try the next 3 on your own. Okay, so on this one, I'm hoping you're seeing that the number that I can take out is a 5, because 20 and 5 have 5 in common, and I can take out an x. So if I divide each one of these by 5x, I get parentheses, I get 4, the x's cancel, minus, here the 5's cancel, and one of the x's cancel, I'm left with 4 minus x. Now I'd like to say 10 goes into 25, but I don't want to use decimals in my parentheses, so I'm going to take out the greatest common factor of 10 and 25, which is 5. So if I take out a 5, and what else can I take out? I have 2 x's here and I have 1 x here. So I can take out 5x, and what do I have left over? I have 2 with an x left over plus 5. And again, you can check these. And the last one, you have 30 and 20. No other number besides 10 will work here. Now, can I take out an x? And the answer is no, because I have no x here to take out. So I have no x's common to both terms. So here I'm just going to take out a 10, divide each of them by 10, and I get 3x squared minus 2. Pause the video if you need to, write down what you need to before we move on to exercise 4. Okay, rewritten in factored form, we have 20x squared minus 36x. I always like to take time to write it down if there's not enough room to work underneath it. So the first thing I'm going to do is ask for the largest number that goes into 20 and 36. So we might have to think about this for a minute. Let's see, what goes into 20 and 36? Well, you might think to yourself, 2 goes in, but there is a larger number that goes in, and the larger number happens to be 4. And we're going to take a look at this in 2 ways. So if we take out that 4 and the x, so taking out the 4x, let's see, what else do we have? So if we divide each of these by 4, what are we left with? We're left with 5x minus 9. So there's our answer, and here is it right here at number 2. But if by chance, and the fact that this is a multiple choice questions make this a little bit easier, but if you decided, like I said before, I know 2 goes in. If you factored out a 2x, what would you end up with? You end up with 10x minus, taking out a 2 out of a 36 is 18. 10x minus 18. We have 10x minus 14, so 15 here, which is not correct. But hopefully you realize here that I still have a 10 and 18, which still has a common factor of 2. So you can say this is 2x, take out a 2 again, and get 5x minus 9. And then just multiply these together to get your 4x times 5x minus 9. So you can do this in a 2-step if you need to, but you need to recognize that you're taking out the greatest common factor, not just any common factor. All right, so although 2 is a factor, it's not the greatest common factor. Okay, so hopefully you understand that one before we move on to exercise number 5. So trinomials can also be factored, and this is where things start getting a little sticky. Okay, now we're going to do the easy ones in 6.2. We're going to move on to the harder ones in 6.3, because all they're asking us to do here is to factor out the GCF, and then into another trinomial. So all we need to look here is with 3 terms, what's the greatest common factor? So in this case, pretty easy to see that if we take out a 2, there's no x's to take out. So if I divide each of these by 2, I get x squared plus 4x plus 5. Taking a look at B, it's pretty obvious that we're going to take out a 5 and be left with 2x squared minus 4x plus 1. Please make sure, remember what that means. If you start with 3 terms, you better end with 3 terms, because 5 divided by 5 is 1. All right, 8, 12, and 20. I'm feeling a 4 here. How about you? But I also have an x, right? So I can take a 4x out of each one of these. And I get 2x squared. Whoop, let's put the 4x on the outside. 2x squared minus 3x plus 5. And the last one, we're going to take out a 3x, because they go into each of these. And we're going to put the 3x on the outside and be left with 2x squared plus 5x minus 7. All right. So another type of factoring you should be familiar with stems from our work in the last lesson. All right. So that's called conjugates. So recall that the conjugate multiplication pattern. This can be reversed in order to factor binomial that have the form of the difference of perfect squares. Usually I call them DOPs. It's a DOPs, difference of perfect squares. All right? So what we're going to do here is recognize that we have a perfect square here, we have a perfect square here, and difference basically means that you're subtracting the 2 of them. So very easily we can factor these. And basically this is just, you don't even have to do a lot of thought here. You know you have a perfect square. We're looking at A right here. We know we have a perfect square in x squared. We know we have a perfect square in 9, and it's the difference. If it was the sum, it wouldn't work. So very important to make sure that's a minus sign. So double parentheses, or one of my student teachers used to call double bubble. All right, and do x in the first term, because x times x is x squared. What's the square root of 9? So what times what is 9? The answer is 3. And then we just put a plus and a minus in the middle. It does not matter what order you put them in. Okay, so how about this one? Same thing, double bubble. Square root of 4 is 2. Doesn't matter, and order matters. All right, so if the 4 is in the first position, the 2 needs to be in the first position. The x squared is in the last position, make sure the x goes in the second position, and then a plus and a minus. Because if we use the commutative property, 2 plus x is the same thing as x plus 2, but 2 minus x is very different than x minus 2. Taking a look at the next one, 4 and 25, both perfect squares. So 4x squared, the square root of it is 2x, because 2x times 2x is 4x squared. The square root of 25 is 5, and we put a plus and a minus in the middle for your signs. And the way that you can double check this is using double distributive. All right, some of you might know it as FOIL, but that's how you can check it. So let's try this one. This is going to be 4 in the first position, plus and minus, 9x in the second position. I'm sorry, that doesn't look like a minus, but it's a minus. All right. So if we just use quickly, let's use one of the easier ones here, like an A. If I use FOIL, I get the first term, I get the outside term, plus 3x. The inside terms, remember you're multiplying them at this point, and minus 9. And when you do this, these two middle terms, which are usually the two we combine, cancel out to get our x squared minus 9. All right, if you had a plus sign here, there's no way that you get these middle terms to cancel out. And we'll talk about that a little bit in our next lesson. So, do exercise 7. Pause the video. You should be able to do this really quickly. And bam, there are your answers. So don't flip out with the fractions, just take the square root of the numerator and the square root of the denominator. So when I'm taking a look at this one right here in C, all right, so the square root of 4 is 2, the square root of 81 is 9, and I do the same thing on the right-hand side. The square root of 49 is 7, and the square root of 9 is 3, all right? Don't forget about the x's and the first terms, a plus and a minus. All right, we just have one more to look at. So we're going to look at exercise 8, and then we'll be done for today. So basically, what we're going to do here is we're going to use a combination of GCFs and the difference of perfect squares factoring, and we're going to write each of the following in its completely factored form. All right, completely factored, 2 words, 2 steps, which usually means we're looking for a GCF first, followed by another factoring move. All right, so if I take a look at letter A, it says 5x squared minus 20. So the first thing we're going to do is pull out that GCF, which I'm hoping you're saying it's 5. So what do we have left over? We get x squared minus 4, and then we say, well, I know that x squared minus 4 is the difference of 2 perfect squares, so that's going to be x plus 2, x minus 2. In B, right away I can see 7 comes out. 7, and then we get 4x squared minus 1. And don't count out 1. 1 is a perfect square. So it's 7, 2x plus 1, and 2x minus 1. Okay, C, I think the most obvious one here, I think, is 10. So if we take a 10 out, remember, we can always keep going if there's another one. So if we take a 10 out, we get 4 minus 25. Oh, I like the fact that I have perfect squares. I think that's what I'm supposed to have. All right, I can't take anything out of 4 and 25, so I'm going to keep that 10 out front and make it 2 minus 5x. Remember, order counts, and 2 plus 5x. And the last one. Now this one I can take out a 3 and an x, and I'm left with x squared minus 16. So keep the 3x on the outside, x plus 4, x minus 4. It's very important that you're really paying attention and understanding each of these lessons, because 6.1, 2, 3, and 4 are all going to build on each other. So if you're not watching these videos, and obviously I'm not talking to you if you're not watching the videos, but if you're not watching them in order and you're not getting this work done and you're just copying and you're really not taking time to understand it, you're really not getting anything out of these videos. Okay, so please, if what I've said to you means you just copied everything down, please go back again and make sure you really understand this so when we start our classwork tomorrow, you're good with it. All right? So until then, make good choices, be kind to each other, and I will see you tomorrow.